And with me I have
John. I was also at Depict with Oliver, and before that I was briefly doing a PhD in reinforcement learning before dropping out, and then before that I was at Peltarian.
Very nice. Yeah, and so what are we building at Tandem? The vision is a co-pilot for clinicians, and this is essentially to allow the clinicians to focus on giving care instead of administrative work. And why do we do this? Well, healthcare admin is actually, it's mind-bogglingly large. It's something like 3% of global GDP. I mean, healthcare in general is 10%, and the admin is about 30% of that. So it's 3% of the global production is actually healthcare admin. And all this admin just detracts from delivering great patient outcomes, which is what we care about. So this is a huge problem. And it's also a very tractable problem due to the recent advancements in LLMs. And so what is the first use case? That is an ambient medical scribe. So what we do is that we generate medical notes based on transcribed patient interactions. So currently, for about every 20 minutes that a doctor spends with a patient, they spend about 10 minutes writing the clinical notes. So what we do then is that we, using our tool, instead of spending 10 minutes after the patient call, they will spend only 2 minutes writing the notes. And so that's obviously a huge time save that they can then use on, well, either having a nicer time or meeting new patients, which translates to more care for less money. And so far, we've seen great initial tractions. We have over 150 doctors on the platform active this month, and we are in talks with kind of all major care providers like Copia and Aleris and so forth, as well as all of the EMR providers. That is the electronic medical record system, or the journalsystem in Swedish. Kind of setting up collaborations with them so that we integrate deeply into their systems. All right, but that's enough talking about Tandem. Let's move on to the demo, and I will actually take over the screen share here. Let's see. All right, so I guess you can see. Yep. All right, so Tandem is a web application. You just log in at app.tandemhealth.se, and then there's really only one thing to do, and that is to start your patient interaction. And because this presentation is in English, we actually have a chance to show off one of the extra functionality that Tandem has, and that is that you can actually detect language. So Tandem is actually available not just in Swedish, but also you can have your patient-doctor interaction in English or in Arabic or in Persian or Spanish, kind of almost whatever language you want. Yeah, so I'm going to do a quick role play here using Tandem just with myself, obviously kind of a fake conversation, and then we'll look at what we produce. All right, so hi, I have a bit of a sore throat. I've had that for about 2-3 weeks, and over the past 2 days, it's gotten a lot worse. I measured my temperature this morning, and it was 39 degrees. I also take Nasonex as a medication for my allergies, and maybe it's relevant, but my father had cancer about 3 years ago, and I had tonsillitis about a year ago. And then the doctor comes in and does its examinations, so checks the lungs, and the lungs sound good, then checks the heart, and notices that the heart also sounds good and normal, and then looks in the throat and sees that the left tonsil is red and swollen, and then concludes that this is probably tonsillitis and that we should prescribe antibiotics to be taken for 7 days, and that the patient should return if nothing has improved. All right, and then you generate the notes. And so that's essentially the flow you go through. Obviously, this is like a very stilted conversation, and the tool is actually very robust to having a more flowing conversation where you talk about lots of details that are not relevant and so forth. But then the audio is streamed to our backend services, where it's transcribed and then thrown away. So we don't actually store any of the audio. And the audio goes through first a regular transcription layer, then a correction layer, where we actually use an LLM to correct the transcription. And we're going to dive a lot deeper into this in a minute. Then after and the transcription actually takes a bit longer in this mode because we switched it to the detect language mode. We also need to translate it from English into Swedish so that we get a medical note in Swedish in the end, which is what is mandated by the law. And then finally, we run that transcription through another LLM to get it out in a structured format, just like a medical note. And what we can see here is that it structures it into, this is just a kind of arbitrary clinical note template. But of course, for whatever clinic that is deploying this, we're going to format it to exactly the format that they have at their clinic. And so obviously the headings you would have for a general practitioner is quite different from a psychologist as compared to a specialist in rheumatology or whatever. So we need to configure the system to work with whichever specialization that we're working with. And of course, this is now in Swedish. So if you don't speak Swedish, you might not know if this is correct or not. But I think people who speak Swedish can verify that pain in the throat is the main contact reason. We had tonsillitis 2023, father with cancer, uses Nasonex towards allergies. Yes, is there a question? I know there's just, yeah. Yes, exactly. So someone suggesting codes, and so actually, in a second we will see that. We also do specify codes. So obviously, we are not suggesting the diagnosis, but we're suggesting the codes. It's really hard to find the code as a doctor. So what we do is we provide this little search box where you can search for tonsillitis, and obviously we're also suggesting, just based on the call that you had, what are the things that occurred in that? And of course, tonsillitis is one of them. And then you can find the JO3.9 code, which is really hard to find in the journaling system. Cool. We also provide some other things around it, like remittances and sick leave notes, but I'm not going to go too deeply into that. But actually, right, just covering the last kind of step of this journey is obviously transferring to the EMR. And so that's actually kind of technically the hardest part of this, is that you actually need to transfer it back to the EMR. And what we have set up is we've set up these RPA solutions where we transfer it to the EMR via some automated copy and paste system or a Chrome plugin and so forth. Cool. I'm going to stop presenting there and go back to the regular presentation. Yes. All right. So yeah, what we just covered, just to recap, there's kind of 3 technical components. It is the speech-to-text module, which takes the streaming audio from the doctor-patient interaction into a transcript. Then there's the text-to-clinical notes, which is another LLM that structures the information from the transcript as a clinical note. And finally, there's a note EMR function, which transfers it to the EMR. And the red rating of this talk is going to be focused on the speech-to-text function. All right. And moving on, then what pieces do we actually use in this? Well, we have actually decided to fine-tune our own model. Why have we done this? Well, because usually I would recommend, if someone is doing speech-to-text, this is kind of a solved problem. Like, just use Assembly AI or DeepGram or whatever. Use one of these systems. You should not be building this. You should be buying it. Well, why are we building it? Well, it's because we are using sensitive patient data. So we need to self-host. We can't send this to anyone. We definitely can't send this to outside the EU. And it's also really important not to send it to, or to send our data to as few people as possible, because every person we send it to is a security risk. And it adds to the complexity of convincing the care providers that we are a safe system. So we decided to self-host this, or it's really the viable option here. And the second reason we decided to fine-tune is that we need to have a really good accuracy on medical terms. So any kind of out-of-the-box Whisper or other open source solution, I mean, they are really good at transcribing Swedish in general, but there's so many medical terms that are really important to get right that they don't succeed at. So that's why. And in the next slide, we'll see that what are the measures of success. So it's really important here to get high accuracy on medical terms. It's really important that we maintain accuracy on Swedish conversation, because the out-of-the-box accuracy is good enough. We don't need to increase that, but we can't lose accuracy on it. Finally, we need to maintain accuracy across dialects. Kind of Whisper as a system is really good at not just rikssvenska or whatever they talk on the radio. It's really good at many different ranges of dialects. And then finally, it would be really beneficial if we end up with a system which can be incrementally improved with new terms. So we don't know all the medical terms right now, new medications come and so forth. And so we need to be able to incrementally improve it. All right, that is it for me, and I'm leaving it over to John.
Nice. Thank you, Oliver. So I'm going to do a bit more of a deep dive into our fine-tuning. And we use a model called Whisper, which many of you have probably heard about. It's a transformer-based speech recognition model that was released by OpenAI in 2022. It does mostly transcription, but it also does translation, and it has these functionalities for language detection and voice activity detection and so on. But the transcription is the part we care about right now. And as I said, it's a transformer-based architecture. So to get the input, you see here, we have the log-mail spectrogram as input. And you get that by taking the audio waveform and looking at 20 millisecond slices in time and computing the frequency contents in that time window. And that ends up as a vertical slice in the spectrogram. So the model is basically looking at an image that is then fed through the encoder blocks. And then there is a decoder which auto-regressively predicts the tokens or the words that were said. Yeah, that's basically it for the model. It's quite simple. It's a pretty standard transformer model. But the secret is really in the data, as it often is. And compared to many previous speech recognition models, Whisper is actually trained only on supervised data. So something like VAV2-VEC2 is trained in a self-supervised fashion. And the reason for that is that it's quite hard to get a hold of lots and lots of transcription annotated audio data. But the OpenAI team managed to figure this out. And they do this by just scraping the internet for lots of transcriptions which they can find. And then they have a lot of heuristics to try to identify bad transcriptions. So like most of the transcriptions you find online, at least the ones you could find 2 years ago, were machine transcribed, which is typically low quality. And so they found these like telltale signs of machine transcribed transcriptions, and they removed them. So they try to get as clean of a data set as possible, but still kind of dirty and just a lot of data. And as you can see here, it's quite small, but it's mostly English. It's like 65% English data, but then there's also a fair bit of multilingual data and translation data. And Swedish is actually quite well represented here. It's just below Italian. So yeah, there's a lot of Swedish data online, and so it can perform well on Swedish. Yeah, as I said, scraped from the internet. If you've read the news in the last few weeks, you might have seen the drama about them potentially stealing data from YouTube. You can definitely say that there's something suspicious going on if you look at the hallucinations you get. So this is something we often saw in our system, at least before we started manually filtering out these terms like amara.org. So what happens is if there is silence in the audio, it can sometimes hallucinate. And typically the hallucination is going to be stuff like, oh, this was a translation by amara.org. And this is not, it does not give a very trustworthy signal to our users. So we get rid of it. But we succeeded with that. We very rarely see hallucinations in practice now, but it's quite funny when you see it. And the performance, so you take this transformer model, you push through a bunch of data, and it works really great. It was the state of the art when it came out. And I think mostly the big benefit of Whisper compared to previous models is its robustness. So in this graph, you can see on the x-axis the word error rate on a split of LibriSpeech, and on the y-axis the average word error rate across some other data sets, which are also just like a common speech, basically. And ideally, you have this black dotted line where like a model that gets 3% wrong on this standard data set should get about 3% on another data set if you generalize perfectly. That's not really the case for most models, of course, but you can see here that the Whisper, which is the purple line, performs much better than supervised models. So Whisper is just zero shot. It's not fine-tuned on these data sets. And all right, so that's Whisper, and Whisper in practice is it's really amazing at English. It's basically human level performance, I would say. It's also really good at Swedish. If you just speak like normal Swedish terms, it rarely gets it wrong, at least if you use a large model. But there is a lot of improvement when it comes to Swedish medical speech. So I can't play the audio here, but here's an example where I talk about some medical terms, some random drugs and so on. And Whisper Small here gets a lot of things wrong. It gets even common Swedish words like lider wrong, but also all of the medical terms except for ibuprofen, which is very common. If you look at Whisper Large V2 instead, it's much, much better. It gets, I think, all of the non-medical words correct, but many of the medical terms are wrong. And yeah, this is not good enough for us. So that's why we need to fine-tune. So fine-tuning Whisper, I think as with most models, it comes down to curating a really great data set, and then you spend some time training at the end. But we spent most of the time trying to get a great data set. It would be great if we could just take our production data from our users, just record the audio, get the text, and use that for training. Unfortunately, that's quite complicated. There's a lot of personal information in this data, and it will be a lot of effort to make sure that it's absolutely clean, because we cannot risk hallucinating personal data, for example. And there's also just legal challenges with using someone else's voice and so forth. So we decided to skip past that and just create this data set ourselves. And we begin with the text we want to transcribe. And we have set up a system where we use LLMs to generate synthetic utterances. So we set up a system with a bunch of different templates to ensure diversity, like 45-year-old man comes into the clinic to check up on X or something like that. And then we've sourced from various sources seed terms which we can use. And that may be common drugs or different medical terminology. And in this way, you get a system where you can just feed a drug like covipenin, and it's going to automatically generate covipenin used in 100 different contexts. So that means that if we want to get good at a specific term, we can just feed it into the system and then get text which we need to generate audio for, and that's the next step. And the main way we've done this so far is with a data collection app that we made. So we gathered up a bunch of medical students, more senior doctors, and other people, and we paid them to go into this app and record audio. So they just log in, they see a text that they should read, where they can make edits if they want to. Usually they don't. And then they just record the audio and they submit it. And in this way, we can create a large data set of very focused medical speech data. And this worked really well in practice. I think one thing to really be aware of when you do this is that diversity is super important. You could imagine just me and Oliver here sitting in a room for dozens of hours just talking, and you would probably end up with a model that's really good at understanding us, but no one else. So we have ensured a lot of diversity in accents and so forth. But we've also started looking at synthetic data. So as you might know, there's been a lot of progress in text-to-speech recently, where especially in English, the quality of the speech you generate is almost human level, I would say. And our early experiments with using this to generate training data are very, very promising. Although we haven't really done the super rigorous experiments to prove like how good is synthetic compared to real and so on, but that's definitely something we're going to continue looking into. And we have this maybe long-term vision where we can get some input from our system somehow that, hey, you often get covipenin wrong or some other drug or medical term. And then we can feed that into a synthetic data engine with the LLM and a text-to-speech system to generate training data, maybe 10, 50 utterances. Then we can fine-tune a model on that, deploy that, and just iteratively get better and better without putting in any manual effort.
John, there was a question. How much data did you collect in this way? I think it referred to the data collection app.
Yes. So we've only done like one round of this, and we collected about 25 hours of data.
Thanks.
All right. So now we have a data set of Tandem medical speech, and we now need to ensure that it's not only good at medical speech, as Oliver said. So I think the first model I trained, I just took a data set with a lot of medicines mentioned, and I trained on that. And I ended up with a model where if I would say, hey, my name is John, it would hallucinate that John is not a name. It's actually, or it is a name, but it's the name of a medicine, and it's spelled really weird. And that's not what we want. So what we do is we mix in data sets with more generic speech. And these are publicly available, like floors, common voice, NST, and so forth. And by mixing in this way, you ensure that the model doesn't get worse, at least on this normal Swedish language. That's it for the data. Let's jump into fine-tuning. So I'm not going to cover in detail exactly how you fine-tune Whisper. You can find like notebooks online from Hugging Face, for example, which are really great. But I'm going to talk a bit about some of the aspects that are usually not covered in these notebooks, but you have to find out and add yourselves. So first of all, what do we train? The first thing to try would maybe be to fine-tune the entire model. We ended up only fine-tuning the decoder, and the reason for that is that we think that the encoder, which is basically some kind of acoustic model, is already good enough from all of the pre-training that OpenAI did. So we don't need to fine-tune it, and fine-tuning it may even risk decreasing generalizability because we overfit to the voices we've seen. So we only fine-tune the decoder. We also don't fine-tune the token embedding layer, because we don't believe that our language is so different from what was seen during pre-training that it warrants updating it. For example, we don't add any new tokens. We also briefly looked into LoRa, so you can do LoRa on Whisper, and some people have done it, but we ended up not doing it because the ecosystem around that is not super mature, so you run into all of these strange issues, and the motivation for us is not so great because we only want to deploy one model. We don't need lots of different LoRas. Yeah, we also aren't really GPU constrained enough that we need to do LoRa. So we just do decoder fine-tuning. Another interesting aspect which helps a lot is augmentation. So for example, if you train an image model, you typically add different augmentations like rotations and so forth. And of course, you can do the same thing in the audio world. We used a library called Augmentations to augment the waveforms. With this, you can do stuff like change the speed of the audio. You can increase, decrease the volume, shift the pitch, or add some background noise, for example. So typically, like when we ask people to record audio, they're going to sit in a quiet room and talk, and that doesn't necessarily reflect reality. But with augmentations, you can add just fake background noise. And that seems to work very well from what we've seen. But an alternative approach is to instead augment the spectrograms. So this was introduced in a paper from 2019 called SpecAugment, where they decide to augment the spectrograms instead. So this is becomes more like an image augmentation. And what some of the things you can do then is mask vertical slices, so removing speech from a particular time, or you can mask horizontal slices, so that is just removing some of the frequency bands. And this is actually what OpenAI used when they continued training Whisper Large and made Whisper Large v2, and it seems to work really well for them. So yeah, we ended up doing this instead. Our most recent model only uses this and not augmentations, but we've also tried combining them. We'd yet to find like the best approach here, but this seems to work really well. So we had a question from Fredrik. What is your reasoning when it comes to augmentation? What is a good share of augmented data versus original data? Yeah, that's a good question. I don't think we have a conclusive answer to that. In our experiments, we found that when we added way too much augmented data, it would overfit to that particular data set. So if you repeat the same data but augmentation. So yeah, I don't have a conclusive answer to that. In the augmentation, did you try cases with background speech? Yeah, so we found some library of noises, which some of them contain a bit of background speech, but we didn't really focus too much on that. But it's a really interesting thing to look at, since there's often background speech if you're in a call center, for example, answering medical questions. So that's an interesting idea. We should look into that. All right, thanks for the questions. Another interesting aspect, I think, is predicting timestamps. So Whisper can actually predict sentence level timestamps or utterance level timestamps by outputting timestamp tokens. And it looks something like this, where you output a token 00.00 and so on. And they do this by just having 1,500 tokens for this. So they have a token for 00.00, one for 00.02, and so forth. And Whisper kind of arbitrarily decides when it wants to output a timestamp token or not. And this seems kind of odd, I think. And in practice, it's not super accurate. It's often wrong. And you can't really control when it should output a timestamp. Although, of course, you can train it for that. I think more importantly, it really complicates training because you require training data in this format. And typically, if you look at common speech, common voice, or floors, or our data set, you just have these single utterances and you don't have these pauses. You could imagine randomly combining different utterances and adding timestamps and having random pauses in between, but that could have like unknown effects on the quality. We instead found a different approach, also from OpenAI in their GitHub repo, where it turns out you can inspect the cross-attention weights to guess timestamps for individual tokens instead. So what this gives you is word-level timestamps instead, which is more consistent, and it also seems to be more accurate from what we've seen in practice. So you can imagine this as like when it's going to output a token, you just see, okay, where does it most attend to in the original image space, and then you get some kind of timestamps. Yeah, that seems to work really well for us. And the reason you want timestamps is if you want to do long form transcription, you need some way to. So Whisper only supports 30-second audio segments. So you need to do multiple, and they might have to be overlapping, and then you need some timestamps to be able to combine these different predictions. Yeah, and then our last aspect, correction with LLM. As Oliver mentioned, this is something that we do, and it's usually very low-hanging fruit. Like if you look at the output of Whisper Small or even Whisper Large, it often makes these like ridiculous grammatical mistakes, which you know that even GPT-3 wouldn't do. And so just feeding the transcription into an LLM usually helps a lot. And you can even take this to the next level, and it's something we started looking at, and that is to utilize the multiple hypotheses that you have during decoding. So what happens when you do the autoregressive decoding with Whisper is you actually maintain multiple hypotheses and do a beam search to find the most likely tokens instead of just greedily picking the highest probability all the time. And so by feeding like the top 5, for example, hypotheses to an LLM, it can really piece things together and find the most likely thing that was said. But that's it. So these are the results of our fine-tuning. Here I only show the large model. We also fine-tuned the small model. But as you can see here, it gets slightly better on common voice, slightly worse on floors, basically identical. And then it gets a lot better on the synthetic data sets we created and also on our real data sets we created. And also, yeah, I think during this, we also noticed that it's very often you can look at the results on the test set and think, oh, this is a great model. Then you try it in reality and it's not really that great. But we've actually been working with this model in practice quite a lot now. And we think this is, yeah, it is actually much better in practice, which is good. And here's an example of an actual output. Yeah, this is the text I showed earlier. Whisper Small makes a lot of mistakes. Whisper Small Tandem is basically almost perfect, except for acetylsyra, which is not a thing. But I'm not sure if I want to blame the model for this, since I'm just quite bad at pronouncing acetylsalicylsyra. So yeah, but yeah, it works really well. And that's it for me.
Awesome.
If there are any questions, we can maybe take them after Oliver's brief.
Yeah. just to wrap things up here, thanks a lot, John. And just kind of restate where we're going with this. So today there's 150 doctors on the platform, and that is growing rapidly. And especially exciting is that we're rolling out with all of the major care provider chains here in Sweden over the coming couple of months. And in not too distant future, we'll be rolling out and enabling doctors all across Europe to enable them to focus on care. And I think some really interesting challenges are going to come there with obviously fine-tuning these speech-to-text models for all different languages. So very excited about that. But we are definitely looking for more engineers to join our team. And we're always looking for just great generalist developers who are not afraid to dig in and solve problems across the stack. And there's a couple of special competencies we're looking for right now as well. This doesn't have to be one person, but could be multiple. It's health tech expertise, just audio streaming and transcription, as you just noted. Windows development, pretty rare, but we definitely need that. Then some security and infrastructure to make sure we don't have any kind of data leakage. And of course, in the end, some front-end and React development for our web application. If it sounds exciting and you want to join us on this journey, or know someone that would want to join us on this journey, please reach out over my email. All right, thanks a lot, everybody. I'm happy to take questions. Nice. All right, Frederick.
Yeah. Can you hear me?
Yes, and nice to see you again, Frederick.
Yeah, nice to see you again. Yeah. Thanks for a really good speech or presentation. I was wondering about, there's a difference between the way you speak and the way you write, right? So when you speak, you get a lot of sounds, etc., etc. So you don't want that. You want to have a coherent sentences when you read text, right? So where do you where do you make this step? Is it in the first model? Because you would have, this kind of speech that I'm showing now with a lot of pauses, etc. Whereas in the written one would be coherent. Is that where that's happening, or is it happening later in the correction model?
So this is something we discussed actually lots of back and forth. And I mean, it's happening in the first model, and it's happening in the data, right? So it's because we have this data set where the transcription is perfect, or it's like something that the thing you wanted to say, but then when the person actually says it, they are adding the ums and the slight mispronunciations and so forth. So that gets encoded into the data and then reproduced by the actual Whisper model. But it is a really interesting question. If you start saying something and you say like half of the word incorrectly, then you correct yourself and go back and say it again. Like, how should that be? Like the half corrected word and then the corrected one, or should it be just the corrected one? And it's not super clear where to draw the distinction.
Yeah. Thanks.
And maybe I should add here also that actually the large language model does help with, if there are any of these ums or things added, it can remove them, of course. So the large language model is really good at understanding what is information carrying and what is not.
We have questions both in chat and raised hands. I think maybe Olivier was.
Okay, yeah, it's a similar question. I guess you talk to doctors, to health practitioners a lot, and do you think there will be a big difference in what you do in the training and so on, and what will happen in production? I'm thinking unexpected thing that may happen. I mean, have you any idea of that? Like, I don't know, a patient crying, or conversation when moving beds, or I don't know what things that are unexpected. Do you have any idea of that, or did you have any? Did the doctors tell you about these things?
Yeah, I mean, so we are running in production right now, and so we are seeing unexpected things happening. They tend to not cause problems in that sense. So if a patient, we've seen things like patient breaking down crying, like that's definitely something that happens, and that does not, like, we don't have a special token for crying, or we don't have anything that that it shows when it's crying. It might even do something wrong. It might say like hi or something like this. But we haven't seen that affecting the quality of the notes, because I mean, even though the transcription might be slightly strange or slightly off, the note will still be really good because you still have this LLM layer after it that is trying to figure out, what if this goes into the notes, and that is usually contained within the speech of the person, and so then it's not really a problem. But yes, there are lots of these unexpected things happening, and of course, lots of weird sounds in the background that you don't expect, and yeah.
Okay, but the model is robust enough. Amazing.
Yeah, especially with the LLM afterwards, right? So even if the transcription gets it wrong, it's not going to do something that causes the notes to be off.
Thank you.
Yeah, so the question in the chat was maybe similar: distorted and unclear speech due to common medical symptoms.
Yeah. Yeah, exactly. I mean, but this is part of when collecting this data is definitely something that is really important to add. In practice, we haven't seen it be a problem with kind of stuffy nose and so forth, but very much, I mean, accents is really important. We've really made sure to have a wide range of Swedish accents because obviously they are really different. Slurred words are usually, like, they can be mistranslated, but usually if you slur them, you will get something that looks kind of like it, and then the LLM will figure out what this was. And so if you slur it, it might be really hard to hear, but then in the end, the LLM will figure out what's going on.
I think generally we would love to collect data on this. I think it's going to be hard to convince sick people to record data for us, but I think most of the reason it works in practice is because Whisper is pre-trained on so much data, and also that we trained on so many different dialects and accents and so on. And for my hoarse throat might sound like Oliver speaking, for example. So it's just general in that sense, and then it works for different medical conditions as well.
Let's take some more voice questions. I think you had one, David.
Yeah, thanks for the presentation. Really interesting. I was wondering, is there any minimum requirements on the hardware, like the microphones that are used, or even the acoustics in the room of that the conversations take place? Have you noticed any situations where you get bad results?
Yeah, definitely. So the quality of the audio correlates really strongly with the quality of the final transcription. What we've found is if you sit in front of your computer mic is definitely good enough, and almost all doctors have a computer on their desk. The problem is if you're over, not by the computer, maybe doing some examination, the quality of the audio is just not good enough. And so what we do is we give out these conference microphones to our users. And those, I mean, they cost like 300 kroner at Shell & Company. We get them for our users, and then it works really well.
Cool. Thanks.
Tobias, had a question?
Yeah. Super interesting. Thank you. I was wondering, not sure if you mentioned that. So in the demo, you record a conversation between a patient and the doctor that you then transcribe and apply the LLM in the end. Do you need to do any diarization as well to figure out who speaks when?
Yes, it's a very interesting question. We've spent a lot of time with this actually. In the first version of the product, we actually did diarization, and that, I mean, it's kind of nice in the sense that when you look at the transcript, it's a bit quicker to figure out who's saying what. But we found that in the end, it doesn't really affect the quality of the notes. And so these large language models, because they're so smart, they can figure out from the context who said what. So you don't really need the diarization, and the diarization really only adds a lot of technical complexity, but it also adds a source of errors that is really jarring. So if the diarization gets it wrong and you go look in the transcript, you're going to be really concerned about what's going on. Whereas if it's just one word that's incorrect, then you're not going to be as concerned. And so we actually ended up removing the diarization because it didn't help improve quality of the notes.
Interesting. Cool. Thanks.
Luminita.
Yes, excellent presentation. Very inspiring. I have a question about this part with self-hosting the model. Like, could you comment a little bit on the back end? Because I work within the region Stockholm, and we have very, let's say, strict rules when it comes to storing sensitive information. So I'm really curious how you do it, like on the backend side with your model.
Yeah, for sure. And so here this comes down to, I think there's kind of two different waves that our company is kind of propelling us forward. I mean, the first one is just a general AI or LLM revolution that's making it possible to do this type, build this type of technology. And the second one is the fact that using open American cloud providers in Europe is now legal. And so if you would have asked someone 2-3 years ago, can you run your healthcare data on Azure or on AWS or GCP, they would have said, no, you can't do that. But over the past couple of years, this has been easing up. And now it's become very explicitly clear that it's legal to run it on whichever, or on the American cloud providers that meet certain criteria. And so we're running everything on Azure in Gävle. So the data never leaves Sweden, it stays inside Sweden, but it is hosted on Azure. And so we're running this in our own Kubernetes cluster there.
That's interesting, because at SL, which is part of Region Stockholm, we're not allowed to do that. So it's quite interesting to hear. Maybe we can get the same rules as you have, guys. Thanks.
Yeah, I mean, what we're seeing is that this is inching closer kind of all the time. And so people who made the decision 2 years ago said no, but people who are making the decision now are saying yes. And so we have regions that have actually started doing it, including care providers in Stockholm themselves are starting to do this. It's just that you will have people who are kind of still sticking with their old decision. Yeah.
Right. Thank you.
Cheers.
Fredrik?
Yeah. I was wondering a little bit if you could, how do you evaluate the quality of the model? Like, what is good enough? And also, do you have any kind of probabilities or confidences coming up from the model?
I guess, John, if you want to add anything on this.
Do you mean the transcription model or the medical notes?
The first one, from audio to text.
Right. Yeah, so Whisper does give probabilities. We don't really use it right now, although we could. And it's something maybe you could consider putting into the LLM layer, where if the probability is low, it would mark it as unintelligible or something like that. And what was your second question?
How you evaluate it.
Yeah, so we evaluate it on the test sets of the common voice floors and so on, also on our own test set and the synthetic test set. And then we have a lot of recorded patient interactions, which are role played, not real interactions, with a bunch of background noise and so on that we've manually annotated. And then we run Whisper in long form transcription mode. And we do some ocular inspection, but we also look at the word error rate to validate it. And then, of course, we also ship it to production, and typically we run it side by side with our original transcription model, and we can compare the results and see if there's any weird behaviors.
I guess here I'm not only thinking about the first model, but just in general, there's you could consider that, or maybe this too bad, so we just say please repeat or something like that. And for that reason, it might be good to have some kind of validation also in production, right? And then also that, some things are more important than others. So just looking at it word by word might not be as good as if you know that there are certain terms. And there I'm thinking, especially if you're doing categorizations, et cetera, et cetera.
Yeah. And so, I mean, I think the clearest thing here that we wanted to improve, right, is the medical terms. And what happens if the medical terms are incorrect is that you will end up with incorrect medical terms in the medical notes. So we track the edits in the medical note. And I think that's the clearest signal towards the transcription being good, is that they don't need to make as many edits in the note itself.
Yeah. Thanks.
Bassam, you have a question?
Yeah, I had two questions actually, but one was answered. It was about the diarization. It's quite interesting that you found that you didn't need to use that, though not that surprising. The other question was about like patient data, because you mentioned that you throw away the audio, which seems reasonable, but like the notes that you generate themselves, aren't they also like very sensitive?
100%. Yeah. So we treat all data in our systems as sensitive patient data. It should of course be noted that we are not the kind of end state of the note. In the end, the note will be transferred to an EMR, and that's where it's going to be stored. And we are not an EMR system. So that just needs to be noted. And then we actually store the notes for 30 days so that doctor can get back to the transcription, get back to the note, edit it before transferring it, and then it's no longer accessible.
Okay, thank you.
And another question from Lumi.
I'm sorry, it's just literally interesting, so I have to ask one more. I mean, this throwing away audio data, it's a huge waste. Do you have any, like, it's like a regulation, I guess. Do you have any, do you look at workarounds to be able to save that in, like, I don't know, on premises or some really safe way so you can actually use that data?
Yeah, so it wouldn't be illegal in any way to store this data. It's just a question of what is our contract towards our, because we are the data sub-processor of the care provider who's the actual responsible for the data. And so as long as our contract with them states that we can store it, we would be able to store it. And we've made the decision ourselves that we it will be easier to sell this product if we don't store the audio data, because then the care providers will have kind of fewer concerns about data privacy. And so that's what we've done. We are looking into talking with specific care providers and getting approval from them for storing their data. And so then having a few select ones which we collaborate closer with, and for them store the data to enable kind of further analysis and further developments.
Right.
But as of now, we're not doing it.
And do you take some direct feedback, like from do you have some direct feedback in the system? Like for example, doctors can say, oh, this was really bad, or?
We do, but on the medical note quality level. And so now in the I didn't show this in the demo, but there's like a 5-star system, but so that's very explicit feedback you can give towards how was the quality here. But also there's indirect feedback, right, which is how much how many edits do you make to the note and how much time do you spend editing the notes. Right. And also, like, is it transferred in the first place? Obviously, some notes will not end up being transferred at all. Then that's a pretty clear signal.
Thank you.
Cool. I had some questions myself also, but I wanted to wait for everyone else first. In the beginning, in the demo, it said something about did you think something was not correct? Please edit, and we will like feed it back to the system or something. Something to that effect. So what happens concretely if you do that?
Yeah. Also, I mean, currently we are mainly working on kind of tuning the prompts for making this work correctly. We are also working on kind of how the entire system kind of how information is flows from the transcription into the final notes. I think it's very clear that we will also kind of tune a model, but currently we're not doing that. So currently it's mainly about tuning the prompts so that they fit better with the output that we see.
Okay. Yeah, and the other thing I wondered, you probably answered already, but I'll say it anyway. So I was thinking about the LLM that corrects the transcription at the end, and you were mentioning GPT models, but then you would be, sending potentially sensitive information to OpenAI, for instance. But I guess that is okay with this setup with Azure in Gävle and so on. Is that the case?
Yeah, you can host OpenAI models on Azure in Gävle, and you can get a special agreement that says that they are not logging anything for any even debugging purposes.
Okay. Yeah, I mean, it certainly makes things easier in the future if this becomes standard in many cases. And yeah, I also really liked your data collection app. We've done similar things in other projects, and it can be a really nice way to improve your models, to just get users and customers involved in collecting data, and yeah, they can come up with things that we can't come up with. And yeah, exactly as you said about variety of data. So yeah, super interesting, and I don't think we've ever had this many questions on any presentation. So
it's a good turnout as well.
Yeah,
I actually have one more question.
Okay, go ahead.
If you don't mind, it's kind of silly, but you mentioned you were moving, or you're rolling out into Europe. I was wondering if you've tested, or if there are any accents that are more problematic than others with this. For example, Scottish accents, Irish accents. There's like it's quite well known that they don't work very well with voice, recognition and.
Right. I'd be very welcome to set up an account for you, and we can try it out and see how well it works. No, so we kind of our go-to-market strategy here is that we are developing a kind of closer collaboration with a few select care providers in Europe, and then going into that market. And so we're not going to go like a big bang type, now we're launching in all the European markets at once, but rather going very narrow and select. And so for whichever market that we end up specializing in, we're going to make sure that it really works well there. I mean, what we see with Whisper in general is because it's trained on such a wide variety of data, it tends to be really good at different accents within languages as well. Obviously, it's really good at skånska, for example, in Swedish, even though you wouldn't really expect that, because sure, it's a very narrow slice of the training sets. But so I think it tends to be really good across dialects. So we're not too concerned about it, but of course, it's going to be super important to make sure that's the case as we roll into these markets.
And I think also we benefit from starting in Sweden, which is like not a super large language, and then moving to markets like the UK or Germany or France should just be easier because there's more data. So that gives us some calm.
Awesome, thanks.
And I think it's also kind of becomes a bit of a moat for us as a company, because if you think about the American providers that would want to do something similar, they're not building this internal muscle of fine-tuning these models and making them really good at all these tiny, smaller languages, whereas we actually build up the muscle so we can be the player in Europe.
Yeah. Great, thanks.
All right, then I think it's time to wrap up again. Super interesting presentation. We will edit the presentation and put it on our YouTube channel, and everyone who missed it will get a second chance to watch it.
Nice. Awesome. Well, thanks a lot for listening. Thanks a lot for all the great questions and for hosting us, Mikael.